Today we're going to talk about logarithmic rules. Remember that a logarithmic function is a function that is the inverse of an exponential function. We write y equals log base a of x. So the baby number, the smaller number, is the base of the function x. And the base can change numbers. You can use a variety. There are two common bases that we use. Whenever you see log written without a base, the actual word log written without a base, it is base 10. That's always assumed. I would not write log base 10 of x. I just would write log of x, and I know that the base is 10. Log base e is actually written ln x. There are rules of logarithms that we can use to condense and expand expressions that are logarithmic. There are different properties that we can use. We can use them actually to solve equations as well. To help us with that, we're going to define these rules now. Starting off with our first rule of logarithms is the product rule. All of these are going to have a base of b just because this works for any log base 10, log base e, the natural log, any of those logs that we're going to use, these rules apply. The product rule is called the product rule because it multiplies two items that are inside the logarithmic function. Notice that I have this m times n. I can expand that to addition. That will become log base b of m plus the log base b of n. If I have multiplication inside when I'm taking the logarithm, I can expand that into addition. And I would like you to remember that there are exponent rules as well. Let's consider the exponent rule x to the m times x to the n. I can condense those to be x to the m plus n. So there's a relationship because logs and exponents have a relationship. There's a relationship between the rules of logarithms and exponents as well. Thinking about what you know for the quotient rule of exponents, what do you think the quotient rule of logarithms is going to be? I have a quotient in here, which is a fraction. That division is going to turn into subtraction. Log base b of m minus log base b of n. And again, the exponent rule would be x to the m minus n. So there's that relationship again. The power rule is when you have something to a power in the logarithm. And the way that we write the logarithm power rule is we actually pull the exponent in front of the logarithm. That's going to be k, it's just an arbitrary variable, times the log base b of m. Whenever you have an exponent, you can rewrite it by putting the exponent in front of the logarithm. Looking at the zero rule, why is it called the zero rule? Let's first explore the relationship between how you can rewrite logarithms as exponents. Let's define the function log base b of x equals y and rewrite it as an exponential function. What I can do here, I like to take an arrow, start at the base, circle around, and hit the x. And what that does is it helps me remember the way in which I write exponentials. That is, b is the base, to the y power equals x. So this is logarithmic form, and this is exponential form. Let's rewrite this log base b of 1 and figure out what that might result in. That means I have b to something is going to give me 1. B to what power gives me 1? Anything to the 0 power is 1. This is actually 0. So if I have log base b of 1 or log base anything of 1, that is always going to result in 0 because only to the 0 power makes a number 1. Let's use that same rewriting idea to help us with the identity rule. B to what power gives us B? Well, I have a single b on one side, which means I need a single b on the other side. Log base b of b is 1. The identity rule is saying b to the 1 power is b. The 0 rule is saying b to the 0 power is 1. So those are two that are very helpful when you're solving equations and condensing and expanding. Inverse properties. Let's break this one into two. Let's say I have, first of all, I have an exponent, which means I can write the exponent in front. And then I have k times log base b of b. Well, I just explored that b to the 1 is b. This right here evaluates to 1, and k times 1 is k. That means that log base b of b to the k power is just whatever the exponent is, because the base of that value, those wind up being 1. B to the 1 is b. B to the what power? Well, if I rewrite this expression using logarithmic form, the base is the base. So I have log base b of something gives me log base b of k. Using the idea of exponential form. Remember, exponential form says if I have a to the x equals y, then that is log base a of y equals x. So notice that the positions change. So here, the base becomes my logarithmic base. And then my exponent becomes on the right-hand side of the equal sign over here. And then whatever my original logarithm is would be here. So log base b, how do I make these two match? It's a k that's missing. So again, this is also k. That means that log base b of b to the k is k, and b to the log base b of k is k. These two operations are undoing each other. That's why they're called inverse properties. The last property or rule that helps me out is the change of base formula. When I'm dealing with a base that isn't common, it's not a natural logarithm, it's not a base of 10, and I want to be able to evaluate it. Calculators now actually allow you to put in whatever base that you want, but some older calculators only allowed you to use base 10 and base e. So we needed to change a base to be able to calculate them. And whatever I use, I call the base the baby number. That helps me remember the baby number goes on the bottom. You can evaluate this using regular log or natural log, either one. The base is on the bottom, and the value that you're taking the log of goes on the numerator. So the base is in the denominator, x is in the numerator. And again, these are just logs base 10. This is also the same thing as natural log of x over natural log of b. And those are just tricks that help me actually evaluate a logarithm that is not normally calculatable with calculators before they allowed you to put whatever base in that you wanted. Back in the day, before we had calculators and computers, there were actually tables of logarithms that people would use to reference. Let's expand and condense a few expressions using these properties. Notice that I have a plus sign here, so I'm going to go ahead and condense this, and then the next two I'm going to expand. So I have a plus sign, and a plus sign to me is a product rule. A plus sign is going to turn into multiplication, and it is multiplication of the two components that the logarithm is being taken of. So natural log of 4, natural log of sine of x. I can rewrite that with one natural log, and then I multiply 4 times sine of x. So I'm going to write that as 4 sine of x. That's the condensing of those two expressions together. In the second expression, that is going to be an expansion because I have some division going on. With division, remember that becomes subtraction. I write the numerator minus the denominator, and it is the natural log of the numerator minus the natural log of the denominator. I don't write natural log x plus 1 minus 2x minus 3. I have to separate them with natural logs. I'm rewriting natural log for each of those. I'm not expanding the x, or I'm not turning the x plus 1 into multiplication because it wasn't natural log x plus natural log 1. That x plus 1 stays inside, and that is finished. Lastly, I have log base 2 of 1 over 8. I'm going to go ahead and expand that because, again, this is division. That is log base 2 of 1 minus log base 2 of 8. I can simplify this further using the 0 rule because 2 to the 0 is 1. And this expression right here actually evaluates to 0. Remember, 2 to the 0 is 1, which means that log base 2 of 1 is 0. That becomes 0 minus log base 2 of 8, or just negative log base 2 of 8. I could actually have asked you to evaluate this rather than just expanding it, because I know that 2 to a power is 8. If I wrote this in exponential form, that is 2 to some number equals 8. That's 2 cubed. That means that log base 2 of 8 is actually the number 3. And that simplifies all the way down to minus 3. Now, I didn't ask you to evaluate this logarithm. I actually just asked you to expand, but I wanted you to see that I can actually take this further. If your teacher asked you to evaluate a logarithm, you can do that. I hope these rules are helpful for you and will help you when you're solving logarithmic equations. Thanks for watching.